But I keep getting total supply is 0 down here. So we have plenty of WETH, plenty of wrap Bitcoin. Are we ever calling this function? We keep getting a total supply of 0 down here. Why is that? How can we figure out if our mint DSC is actually getting called? Let's first off see if this mint DSC is even being called. We can use something called a ghost variable to track this. So in here, up at the top, we'll make a function called uint256 times mint is called. We'll make this a public variable. And at the bottom of mint DSC, we'll do times mint is called plus. Now, back in our invariants, we do a console.log times mint called, comma, handler.times mint called. And then we'll run our test again with -vv. And we can see, oh, mint is actually never called. How is that possible? Well, it must be because one of these returns is hitting and it's not finishing this call. So we could keep moving this up to figure out where it's actually being called and to continue to debug this. But I already know how to debug this, of course, because I've done this a while. If you want, take this as a challenge for you to answer the question, why is this never being called? Why is times mint being called, never being called? Why is it never finishing? So feel free to pause the video, try to debug this yourself and find out. And then I'll tell you the technique that I used to debug this and figure out why this mint DSC was never being finished. All right, welcome back. Did you actually pause the video? Did you actually try to figure it out? If you didn't, I'm giving you a second chance. Pause the video, go find out. Pause the video and take this as your opportunity to try to debug, okay, why is this not getting hit? Why is this line not hitting? All right, welcome back. Now, there's a couple different ways that I used to actually debug this. One of them was having this times mint called plus equals 1 and then moving it up till I found the line that it was breaking on. Once I found the line that it was breaking on, I console.logged all the values of the different variables around. One of the most important variables that I dumped was going to be the message.sender. So when you're working with invariants, remember, it's going to call this contract with a ton of different functions and a ton of different calls. However, it's also going to call them with random addresses as well. So in order for us to mint DSC, we need to only mint DSC with an address that has actually deposited collateral, because it's impossible for someone to mint DSC without them depositing collateral. Now, again, if we restrict this function like this, maybe there is a case where you can mint DSC without depositing any collateral that we don't know about. This is, again, why it's important to have some open invariant tests, some continue on revert, and some fail on revert as well. So if we want to have this be fail on revert, we would need to only pick a message.sender that has some deposited collateral. So what we can do is actually keep track of people who have deposited collateral. And then when we go to mint, we just choose an address from somebody who already has deposited. So how can we do that? Well, we can just keep track of an array of addresses that have collateral deposited. So up at the top, well, let's actually keep this times mint is called, and we'll put it at the bottom, times mint is called plus plus. And this way, we know how to test this, right? If times mint is called increases, we will know that we fixed the actual issue. So times mint is called plus plus. Up at the top, we'll do a address array, public users with collateral deposited. We'll copy this address. And now in deposit collateral, users with collateral deposited dot push message.sender. Now there's some caveats here. This will double push, obviously, some people. So this will double push if the same address is pushed twice. But for now, let's just keep it simple and let's go ahead and just leave it like this. We probably should check to see if someone has already deposited collateral, but whatever. We're going to go with this for now because it's simple. And then Now in our Mint DSC, we can do something similar to what we did with collateral. So we'll do a underscore uint 256 address seed. And instead of bounding to message.sender, what we can do is we can say address sender equals users with collateral deposited. It's going to be the index of the users with collateral deposited of address seed mod users with collateral deposited dot length. And now instead of message.sender, we're going to use sender in here. And same thing with down here. We're going to use sender. Now let's run this and see if Mint is ever actually called. Aha, so this was very helpful. Redo it. Let's do -vv. Ah, okay. So at least we're getting something different here, right? We're getting an error, division or module by 0. Ah, okay. Of course, we're getting module by 0. Because if the collateral length is 0, then obviously sender is going to be 0. So we can do if users with collateral.length equals 0, then we're going to return. We're going to skip this one. So let's run this again. Ah, okay. So we're getting some stuff passing. Let's actually just do it 2 V's so that it's easier to read than all those events. Aha! Total times Mint was called is now 31, and we're getting a total supply. So our Mint DSC function in our handler is now actually working. We're now successfully calling Mint DSC, and it looks like our protocol is holding up. All right, it's fantastic. So we're getting closer to building this handler to actually have a solid recreation of all the possible functions we can actually do in this system. Something I didn't show you was we should pretty much always use a given invariant called function invariant getters should not revert, like this. And then we just put in here all of our invariants, like dsce dot get liquidation bonus, dsce dot get precision, etc. Put all of our getters in here, and this could be public view. And if any of these revert, then this will fail. This invariant test will call a ton of different functions on the handler. And if any of the function combinations break any of our getters, we know we broke an invariant. This is a layup invariant that everyone should always 100% include. A way to make sure that you're including everything is you can run something called forge inspect DSC engine methods, and it'll print out all the different methods that this function has in addition to its function selectors. So you can kind of use this as your checklist of all the different functions you can call on a contract, and you can look for all the view functions in here. This is additionally why it's great to have get in front of these words, because it becomes very easy to figure out which ones are getters.